Okay, this is our lecture 4.4, and it is on graphing polynomial functions. The essential standard is I can evaluate polynomial functions. For polynomial functions, I can determine the end behavior and I understand the relationship between the number of zeros, the terms, and the degree of the polynomial. Those are the relationships, okay? The zeros, terms, and degree. Using a table of values or a graphing calculator, I can approximate the zeros and relative extrema. All right, a polynomial is in one variable, okay? One variable, such as x, is an expression in the form as seen here. Okay, so let's talk about what's going on here. So here is my x to the nth power. If it's a polynomial, the n has to be a non-negative integer, and the a to the n is the coefficient that is in front of that x variable to the nth power, coefficient being like maybe a -3 or a 2. Okay, then you'll notice that the following term, separated by addition or subtraction, is the x to the exponent that is one less than the leading um, or the highest degree. Okay, so what is it? What I'll give you an example. So let's assume that's x to the 10th. Then the next term would be x to the ninth. Okay, and it too has a coefficient. So potentially it could be a 1, could be a -1, but at any rate, it has a constant in front of it, and that is called its coefficient. We will continue the process all the way until we get to the x to the 1 power with its coefficient in front of it. And then although you don't see it, this is technically x to the 0 power. So that's a to the 0 times x to the 0. And the reason why people do not write x to the 0 is because that is 1. So they don't include that. Okay, now all of those exponents that are listed, again, don't forget, have to be non-negative integers. So we cannot have a fractional exponent, which is some type of root or radical, or we cannot have a negative exponent or the combination of the two, non-negative integers. Okay, and in addition to that, all of our coefficients have to be real numbers. Okay, the polynomial is in standard form when the terms are listed in descending order by exponent. So x to the 10th, to the ninth, to the 8th, to the 7th, and so forth. And sometimes you might skip one because we don't have a term that's x to the whatever, fifth. Okay. The degree of the polynomial, so we have to understand what that word is. The degree of the polynomial is the value of the largest exponent. So in my situation where I had an example, it would have been 10. The 10 would be the degree of the polynomial. And then one more very important definition, the coefficient on the term with the largest exponent is given a special name and is called the leading coefficient. So that would be the a to the n, which is multiplied times um, uh, the largest term with the largest exponent. Okay, so let's just do some examples. Is the polynomial in one variable? And if so, state the degree and the leading coefficient. Is this polynomial one variable? So if I look across on A, I only see x's. There are no other variables. So the answer is yes. It is in one variable. So I've answered that question. If so, state the degree and leading coefficient. Well, what is the degree? The degree is the largest power, the largest exponent, and the degree in this case is 5 because I have x to the fifth. Okay. Okay. And what is the leading coefficient? And in this case, the leading coefficient is a positive 8. Okay. So there we go. We've answered the question. B, is the polynomial in one variable? Well, I see I have a y here. So the answer is no. What is the reason? There are two variables, x and y. All right, why don't you try one yourself? Welcome back. Is the polynomial in one variable? Hopefully you answered yes, there are only x's in this polynomial. What is the degree? This is not written in standard form, but the degree is 8. And what is the leading coefficient? And hopefully you notice that it is a -4. Okay, all right. Once again, try one yourself. Welcome back. Is this polynomial in one variable? Well, it is in one variable. All I have are x's. However, this is not by definition a polynomial. And the answer is no, because this term right here is the same as 4 times x to the -1. So you can say no, 4 times x to the -1 is a term. Terms are separated by pluses and minuses with a negative exponent. And we have to have only positive, I'm sorry, we can only have non-negative exponents, non-negative integer exponents, so can't be a fraction. All right, polynomial functions are evaluated in the same way as all other functions. So replace all the variables in the expression with the input value if you're asked to find the let's say value of this polynomial. If, for example, x was 2. So in this situation, what would we do? We would write f of 2, not f of x, is equal to 3 times 2 cubed minus 4 times 2 squared plus 2. And that would be the same as, well, 2 cubed times 3 is 24. 2 cubed or squared is 4. 4 times 4 is 16. That's minus 16. I still have my plus 2. And the value of that expression is 10 when x is 2. All right, what do we do on the next one? We have find the value basically of f of a cubed, and then if f of x is equal to that particular expression. So what do? We basically take a cubed, and everywhere there's an x, I plug in a cubed. So a cubed is my x value, and then I have to cube that. That is probably an area people make mistakes. So focus on what that means. My x is a cubed. Then I have to cube a cubed, okay? So minus 3 times x, which is a cubed, and then I have to square that, plus 8 times x, which is a cubed, plus 1. All right, and then I have to simplify. So a cubed is a to the 9th minus 3 times a cubed squared, which is 3 times a to the 6th. I have to multiply my exponents, and then plus 8 times a cubed, and then plus 1. And let me just make sure this is clear because my A's and 9s are starting to look a little similar. There we go. And there is the answer. All right, why don't you try one? Welcome back. So what am I doing? I'm taking 2x plus 1, and everywhere there's an x, I actually have to plug in 2x plus 1. So the value of the function when x is 2x plus 1, I will take 2x plus 1 and plug it into this x value. And what do I have to do to it? I have to square it. The x was squared. Minus 3 times 2x plus 1 plus 5. All right. Now, I have to evaluate this. How do I do that? I take 2x plus 1 and I multiply it twice. or I square it, same thing, right? And that requires me to FOIL. And once I do that, I will get 4x squared plus 4x plus 1. So 2x times 2x gives me 4x squared. The inner terms, it gives me 2x plus 2x, which is where 4x came from. And 1 times 1 is 1. All right. That is a little bit too long. And then I have to subtract. What am I going to subtract? I'm going to subtract. I have to multiply the 3 through the entire term. And that will give me 6x minus 3. So I have to multiply that -3 through the entire term. So -3, let me include that negative there. -3 times positive 2x gives me -6x. -3 times positive 1 gives me -3. And then the last I have +5. Now I have to simplify. So I have 1x squared. I have 2 x's and I have my constants. So I have 4x squared, and then I have 4x plus minus 6x gives me minus 2x, and then I have 2 constants, and those added together give me a +3. Oh, I must have left a negative somewhere. Nope, no, I didn't. So +1 plus 5, +6 minus 3 gives me a +3. There's my answer. Okay. All right. The number of times that a non-zero polynomial can intersect the x-axis is the same as the degree. Let me restate that one more time because I left out a very important word. The maximum number of times. Okay, so that's the max that a non-zero polynomial can intersect the x-axis is the same as the degree. So a constant function with a degree of 0. So instead of y equals mx plus b, the degree is 0. So it's just going to be y equals some constant number. Okay, I'll call it m. And sure enough, I get a horizontal line. And so this horizontal line, the maximum number that it can intersect the x-axis is 0. Now, if I have y equals, let's say mx plus b, now I have a degree of 1. I'm just showing you what this example is. And without a doubt, it's actually going to intersect the x-axis 1 time. The maximum number, it is going to intersect that x-axis is 1 time. And then x squared, you've seen this before. It doesn't have to, but the maximum number that it can have is 2. So we're starting to see the pattern. Here's 3. Its maximum number of times that it can intersect the x-axis is 3. Again, 4, the maximum number of times I can intersect the x-axis, which will give me 4. The degree is 5, and the maximum number of times that I can intersect the x-axis is 5. So the maximum roots are 5. Now, it doesn't have to have 5, but that for sure, they cannot have more than 5. Okay. I'm not sure where those came from. Let me stop for just a second. Okay, so we're continuing on, and this next section, I have a feeling might be a little tricky, but if you focus on what's happening and not memorization, you will do better than if you try to memorize this, okay? In behavior of polynomials, what does that mean? The in behavior of a polynomial function in expanded form is determined by the largest degree. We're going to focus on the largest degree term. So which one has the largest exponent? And we're going to look at some things. Use that term, we're going to use that term to find the in behavior of that polynomial as x approaches infinity. So as x approaches positive infinity, and as x approaches negative infinity. So what does that mean? Over here to the right, as x approaches positive infinity over here, what is my output doing? Well, in one situation, I am going towards positive infinity. So the output, the y value, is headed towards positive infinity. And another polynomial, as x approaches positive infinity, the output, the y value, approach negative infinity. And we could evaluate the same thing as x approaches negative infinity. Okay, so that's what we're talking about when we are talking about the end behavior. What is happening to the output or the y value of the polynomial? All right, if the polynomial is in factored form, if it's in factored form, if you recall in our quadratics, we had factored form as x minus q. There was our factored form. Those values were our intercepts or our roots. We actually could quickly determine what the solution was for that particular quadratic. So if a polynomial, maybe it's to the sixth term or sixth power, is in factored form, we could analyze each factor and combine the results together to determine the end behavior, okay? All right, is the polynomial an even degree or odd degree polynomial? Is the leading coefficient negative or positive? The most zeros this polynomial function can have is what? And then describe the end behavior of the polynomial function. All right, we're going to focus a lot on the first term. That's going to help us answer pretty much every one of these questions. Okay, so A, f of x is equal to what's given? The question is the degree even or odd? And since it's to the eighth power, 8 is even, so it is an even degree, okay? Is the leading coefficient positive or negative? Well, since the leading coefficient, let's just put that right here, since the leading coefficient is -3, therefore it is negative. Okay, what is the max number of real zeros? The max number of real zeros is the max exponent, which is 8. Now, we have to describe what happens when the value of x approaches infinity, I'm sorry, negative infinity and positive infinity. What we're going to do is we're going to ignore all of the other terms. We are only going to focus on the term with the largest exponent, because essentially if I put positive infinity or negative infinity and take it to the eighth power, all those other terms are not going to change the behavior of the end of that polynomial. Okay, this is going to be so much larger than the rest of those terms. They don't have an impact. Well, they have a little bit of an impact, but very minimal as it approaches infinity. So what do we want to do? We want to take that -3 and think of putting in, we're going to evaluate negative infinity first. So we'll put negative infinity in for x and we'll take it to the eighth power. Well, if I have a negative number to a even power, that is going to give me a positive number. And then I'm going to multiply it times a negative coefficient. So my result will be a negative number. So as x approaches negative infinity, my output or my y value will approach a negative infinity because of this evaluation that I just did right here. Okay, now let's do the same thing with um, as x approaches positive infinity. So I have a -3. I'm going to put positive infinity in there for my x values, and I'm going to take it to the eighth power, positive number to a positive 8 times a negative coefficient. That's going to give me negative infinity as well. Okay, so again, we are going to focus on the leading term in the polynomial to answer these questions. So why don't you try one yourself? All right, welcome back. It's important you try these yourself so you can figure out if you're doing it correct or not. All right, so let's see. Is the degree even or odd? It is to the fifth power, therefore it is odd. Is the leading coefficient positive or negative? It is negative. The max number of real zeros, since it's to the fifth power, the maximum number is 5. As x approaches negative infinity, what does f of x do? Well, since I'm going to pay only attention to the first term, or the, when it's in standard form, I will take my -4. I can think of putting in negative infinity and take that to a fifth power. Any negative number to a fifth power will give me a negative number. I'm going to multiply it by a negative number. I will have a positive output. Therefore, my polynomial will approach positive infinity as x approaches negative infinity. Let's see. what do I do now? I evaluate the same thing, except I do it for positive infinity. So -4 times a positive infinity to the fifth power. Positive number to a fifth power is positive, multiplied times a negative gives me a negative number. So I will go to negative infinity. Okay, so that's this evaluation, and that is this evaluation. Okay, all right, what about this next term? I have negative x times the quantity x plus 4 to the sixth power. Is the degree odd or even? Well, this one might be a little tricky, so think about this. I have, if I were to multiply this term out, okay, if I were to take this x plus 4 and I would multiply it times itself 6 times, the maximum the maximum term, the maximum exponent that I would have would be x to the sixth. And then I would have this negative x out there. So my degree will be odd because my maximum value will be x to the seventh. Okay. Is my leading coefficient positive or negative? Well, once again, if I do the same evaluation, I'm going to have this negative um, that will make my leading coefficient negative. Okay. Then, because this is in factored form, I know that I have a maximum of 7 roots. However, because it's in factored form, I can actually determine its roots or its solutions. Negative x times x plus 4 to the sixth, I can set that equal to 0. I know negative x equals 0, so x equals 0. I can also set x plus 4 to the sixth power to equal 0, take the sixth root of that, and I can find x to be -4. And that is how we got these two values. So we can actually know that instead of having up to 7, I only have 2 in this situation. So it only crosses the x-axis twice. Now I need to evaluate when x goes to negative infinity, what does the output, what is f of x, how does f of x behave? What is the end behavior? Now, this is tricky, so be careful. I need to replace each x value with negative infinity. So what does that look like? Well, I have a negative x. Well, x is going to be negative infinity. Then I have negative infinity plus 4, that term will be to the sixth power. So that negative infinity to the sixth power will end up being a positive value. And then on the outside, I have a negative times a negative, so I have a positive value again, which will give me a positive infinity. Then I do the same thing. Let's just put that here. That's all this. I do the same thing as x approaches positive infinity. So remember, and the positive infinity will go where x is. So I have a positive infinity plus 4 to the sixth power. So a positive number to the sixth power is going to give me positive, and on the outside I will have a negative, and so this will be a negative infinity. Okay, let's do one. Why don't you try it yourself? Okay, this one again is might be a little tricky, but hopefully you're starting to see the approach. All right. My first term is x to the -2 squared, and my second term is x plus 8 to the fifth power. Is my degree odd or even? So my first term, x minus 2, if I squared that, multiplied it out and FOILed it, my largest exponent would be x squared. I'm just going to put that down there. That would be x squared. Then the second term, x plus 8 to the fifth power, if I multiplied that out, I would have my largest term be x to the fifth. And I multiply the x squared times the x to the fifth, I would have x to the seventh. So I will have an odd degree. Is my leading coefficient positive or negative? Well, both the x's in the terms are positive, so I'm going to have a positive leading coefficient. Just think about FOILing all that, okay? Number of real zeros. Since it's in factored form, I can actually set that expression equal to 0 and solve for the values of x's. It can have a maximum of 7. However, in this case, it only has 2. It gave it to you in factored form. You can set that equal to 0. You can find x to be equal to 2 and -8. Okay, so that's where they came from. Now we got to determine what the end behavior is. I'm going to evaluate those expressions by putting in negative infinity for x. So what does that look like? I have negative infinity minus 2 and squared, and then I have negative infinity plus 8. I'm going to take it to the 5th power. Well, negative infinity on the first term, let's look at the first term. If I have it to a squared, that negative will become positive. So this is going to give me a positive value. However, on the one that has to the 5th power is going to give me negative. So that is going to go towards negative infinity. And then I will do the same thing in this situation. And I will find that I have positive infinity to minus 2 squared, positive infinity plus 8 cubed. Obviously, the minus 2 and the plus 8 really don't make any difference whatsoever. I have positive number, positive number. This will go towards positive infinity. Okay. All right. In behavior analysis will show that odd degree polynomials will have one side up and one side down. Okay, we're moving on to the next concept. So let's think about this. In behavior analysis will show that odd degrees will have one side up and one side down. As a result, odd degree polynomials will have at least one real zero. Even degree polynomials will have both sides up or both sides down. As a result, even degree polynomials do not have to have any. We could have 0 real zeros, could have no solutions, okay? You've actually seen this before. So let's take the odd one. So odd would be something like, I don't know, y equals mx. That's a line. It's to the 1 power. That is odd. No matter what, we will for sure have a 0. And notice that we have one side up, right? One side is up and one side is down as far as its end behavior. As x goes towards a positive infinity, y went towards a positive infinity. As x went towards a negative infinity, y went towards a negative infinity. Okay, so we had one side up, one side down. How about one that you've already seen to an even number? Right? How about that? You could also have it look like that, right? So even degree polynomials will have both sides up or both sides down. And I've given you 2 examples. And in addition to that, they don't even have to cross the x-axis. Now they can. It can, our quadratics can have 0 roots or 2 complex solutions, 1 real or 2 real. Okay. All right. Describe the end behavior of the polynomial function. So now we're kind of going backwards. Okay. So let's see if we can describe this. Describe the end behavior of the polynomial function. Does the graph represent an even degree, odd degree polynomial? And is the leading coefficient negative or positive? And how many zeros does the polynomial have? All right. When x goes towards negative infinity, so I'm headed off to the left, what does the output do? Well, f of x goes towards a positive infinity. As x goes towards a positive infinity, what does f of x? It goes towards a positive infinity. Is this function that is graphed, is it degree, even, or odd? Well, both of the endpoints are going upwards. Well, remember your quadratic, both went upwards. So it has to be an even degree. Is the leading coefficient positive or negative? You evaluate, how do you answer this question? Evaluate the end on the as x goes to positive infinity. Okay, so in this situation, as x went to positive infinity, what did y do? It went to positive infinity. So we did not multiply it times a negative number. We didn't flip the sign. So it is a positive coefficient, okay? Number of real zeros, 1, 2, 3, 4. I have 4. Let's do another one. When x goes to negative infinity, what does this function do? It goes to negative infinity. The output goes to negative infinity. When x went to a positive infinity, what did the output do? What did y do? It went to a positive infinity. Is the degree even or odd? Well, we got to look at the end behavior. I went up and I went down. And we know a line, which is an odd number, has up and down. So therefore, it must be odd. Is the leading coefficient positive or negative? Well, what's happening on the x side? As x goes to positive infinity, is y going to positive infinity? Yes. So I didn't flip the sign, so it's got to have a positive number. And then the number of real zeros, 1, 2, 3, 4, 5. I have 5. Okay, how about trying one yourself? Okay, welcome back. As x goes to negative infinity, that's this direction, what is happening to y? It has a positive infinity. As x goes towards a positive infinity, what is happening to y? It goes to negative infinity. What is the degree? Well, I have one up and one down, therefore I have to be odd. Think of a line. Is the leading coefficient positive or negative? Well, what is going on the x side? As x went to positive infinity, did y go to the positive infinity? No, it went to the negative infinity. So I had to multiply that leading coefficient by a negative number, excuse me. Number of real zeros, 1, 2, 3. Okay. All right. Graphing polynomials by hand is realistically beyond the scope of this class. Advanced mathematics, which is calculus, is required. When you take that, you're going to have to do a good job of graphing polynomials. However, point plotting can generate good graphs. In other words, if we can find the roots and estimate the number of turns, you can actually sketch the shape of this graph. Just make sure that you have enough points that are plotted to match what is known. In other words, what is known about the end behavior. This is best done with technology. What does that mean? That means calculator or computers at this point in your math journey. Now, how about this? This is an actual function or question from the SAT. Why don't you try it? Welcome back. If the function has 5 zeros, it has told you how many zeros it has. Which of the following could represent the complete graph? Well, let's count them. 1, 2, 3, 4. That's not 5. 1, 2, 3, 4. Not 5. 1, 2, 3, 4, 5, 6. Not 5. 1, 2, 3, 4, 5. Only one with 5. All right. Hope that makes sense. Take your time on these. Ask me if you have any questions.